Let's take a look at calculating present value. So the formula for present value is P is equal to A times 1 plus I to the power of negative n. And it's kind of hard to see that negative sign, so I'm actually going to rewrite it larger. So P is equal to A bracket 1 plus I to the power of negative n. So this looks similar to the compound the compounding formula, but there's just a few variations on it, and we're actually looking for the opposite. So what we're doing here is we are looking for how much money needs to be invested today to have a certain amount of money in the future. So in this case, our A, our final amount, is how much we want in the future. And our P, this is how much do we need to put in right now to have that amount of money in the future. So let's take a look at our question and get going. So question number 6, Rob needs $15,000 in 8 years to help pay for a new car. How much should he invest today at 2.4% interest compounded quarterly in order to have that money? So let's start off by putting down what we know, what we don't know. So we don't know what P is. So in this case, P's are principal still, but we can also refer to it as present value. Our A, our final amount, we know how much this is now. This is $15,000, and Rob wants to have this in 8 years. So our I is going to be 0.024, right? So 2.4% written as a decimal. And this is divided by 4 because we are compounded quarterly. And we can simplify this and write it as 0.006. N, total number of compounding periods. So we're compounding 4 times a year for 8 years. And this is going to give us 32. So our equation, P is equal to, or actually our formula, P is equal to A times 1 plus I to the power of negative n. So A is 15,000. We have 1 plus 0.006 all to the power of negative n. Oops, and we don't want negative n there anymore, do we? We want to actually put in some numbers there. So negative 32. Okay, and again, if you have a scientific calculator, you can just punch this all in one go. And if you don't, then you need to make sure that you're doing the exponents or the part with the exponent before multiplication. So our answer here is approximately $12,386.71. Okay, and let's actually practice doing a paraphrase here. We haven't done that yet. So therefore, Rob should invest $12,386.71, and he's investing that today so that in 8 years he will have $15,000 to help pay for a new car.